It's a question that keeps some awake at night. Are there advanced civilizations out there? Civilizations light years ahead of us. Think about it. The Earth is a newcomer on the galactic scene. We've only been around for 4.5 billion years. The galaxy is more like 10 billion years old. There could be civilizations out there, billions of years more advanced than we are. And considering our progress over just a few decades, 1 billion years of advancement is a mind-boggling prospect. Some astronomers try to imagine just what such ETs might have achieved.
We have ignition.
The advanced civilizations out there have vast telescopes, almost certainly.
Their astronomers have already cataloged the sun. They've already noticed that the sun is orbited by many planets. They have probably discovered that one of them is like the Earth.
They have mechanisms by which they can listen to our electromagnetic communication. They're listening to this interview right now. Why not? They can store it all away. Maybe they're taking pictures as well.
It all sounds like crazy talk, but what's inspired these astronomers to hunt for ET is the recent discovery of just how many potential Earths could exist. Back when I was a young astrophysicist, we didn't know of any other planets outside the solar system, let alone other Earths. Indeed, there were scientists back then that argued there's probably very few Earths anywhere in the galaxy. Well, that view has changed radically.
The galaxy that we live in with its 200 billion stars is packed with Earth-sized planets that are lukewarm. Almost certainly many of them have water. Some of those worlds will have some continents in which primitive life can spring forth, and Darwinian evolution would lead, presumably, to technological, dexterous, vocal life as we Homo sapiens are.
So looking for ET may not be so crazy after all. There's nothing new about searching for evidence of aliens. Astronomers have been pointing their radio telescopes at the skies for decades, hoping to find one of ET's signals. So far, without success, I should say. But now, there's a new way of searching for ET.
We have a marvelous new technique for hunting advanced civilizations.
It involves laser beams. These consist of pure colours, a single frequency of light. A natural process is unlikely to produce them, so find these in the galaxy and you'd have evidence for ET. Not alien dance parties, but alien laser communications.
The advanced civilizations would have colonies, they would have spacecraft, maybe they've colonized other planets, and they would be communicating with their brethren.
While we communicate with our spacecraft using radio waves and tracking stations, like the one here at Tidbinbilla, even NASA might soon switch to laser communications.
Yeah, certainly they would like to actually particularly use it when we eventually, one day, send humans off to somewhere like Mars. So rather than just getting a radio signal and hearing those voices from that planet or seeing just individual still pictures, we could get video streaming directly from the red planet.
The great thing about lasers is that they can be very high frequency, blue light, ultraviolet light, and so you can send a very high bandwidth of information, something like 1 with 12 zeros after it worth of bits per second.
So, Jeff is using the Keck telescope in Hawaii to look for evidence of alien lasers. We'll catch up with his search shortly. But meanwhile, Jason Wright is looking for a different kind of alien technology. Dyson spheres.
So Freeman Dyson, the brilliant physicist and polymath, hypothesized that very advanced civilizations would need a lot of energy, and so that they would build lots of solar collectors around their stars to gather all of this energy.
We are putting solar cells everywhere. We're gonna put them more and more and more and more. Pretty soon we're gonna cover the whole Earth with them. Well, why not just put a whole sphere around the sun and collect all the energy from that? That's a Dyson sphere.
If these exist around stars, the laws of physics dictate we could detect them. Because whenever energy's used, heat must be produced.
When your computer uses energy out of the wall, after doing lots of interesting work with it, your computer warms up and it gets rid of that energy by giving it away as heat. So in the same way, advanced civilizations that might be collecting huge amounts of power from their stars will have to give that energy away as heat when they're done using it.
Jason's hunt for Dyson spheres in our galaxy is just beginning, but he's already completed perhaps an even more interesting search. To understand it, you need to know about the Kardashev scale. It's a way of measuring just how much more developed than us ET could be.
The Kardashev scale was invented by Nikolai Kardashev, a Russian astronomer.
There is an imaginary set of stages that advanced civilizations will aspire to.
It's basically a way to categorize civilizations by their energy use.
A Type 1 civilization is one that's still confined to its own planet, but using pretty much all the energy resources there. We puny Earthlings might reach that stage in a couple of centuries. Type 2 is using all the energy of their star, with, say, a Dyson sphere. A Type 3 civilization has gone one step further and moved out into its galaxy and commands the energy resources of many, many stars.
The final level would be to build a sphere to collect all of the energy from its entire galaxy, all 200 billion stars, or a large fraction of them.
They might even be extracting the energy from the giant black hole at the centre of their galaxy.
It doesn't matter what they do with the energy. They might be building giant computers or Death Stars or lasers or rocket ships or whatever it is. If they're using the energy, they have to get rid of it as heat when they're done with the energy. And that's all we're looking for. So we hope that this makes us less dependent on guesswork about what an advanced civilization would be like.
Jason combed through the WISE telescope data, looking at many thousands of nearby galaxies, and came up with a clear result.
We can show that there aren't any galaxies out of the 100,000 that we studied in the sky that are filled with civilizations using most of the starlight. So we can, for the first time, rule that hypothetical class of civilization out.
But not all's lost. The other classes of civilization could still be out there. Meanwhile, Jeff's laser hunt in Hawaii is well underway. Catalyst ventured here a couple of years ago to visit the high-altitude Keck telescope. OK, we're at the top, 14,000 feet. That's more than 4 kilometres up. I must say, I feel very woozy. It's like I've had a couple of wines. The Keck is an optical telescope, so it can look for alien laser light. And it's massive. That mirror is 10 metres from side to side. Incredible. Jeff points the Keck at a star, collects all its light, then looks at the colours present in it.
We're watching to see if there's any bright beams of light at just one color that would be the lasers from any advanced civilizations that live there.
To maximise the chance of success, another space telescope, the Kepler, lends a hand. Kepler's already identified many stars that have planets. And these are ideal candidates for Jeff to point the Keck towards. The first part of the search is to take a kind of crude quick look, and that's already been completed.
And to tell you the bottom line, and frankly, we haven't announced this publicly, but I'm happy to do so, we didn't find any. We looked really hard, 2,000 stars, we didn't see a single laser beam.
It was a disappointing result, but it's part 2 of the project, a detailed search for lasers that will be most interesting, and that's only just beginning. Now, it's still early days, but what if we find nothing? Well, advanced aliens could still be out there.
Maybe they are, and we just don't recognize it as such. They're so far beyond us as we are to, say, ants. We wouldn't even think of talking to an ant, so why would these civilizations think of talking to us?
Or maybe there are no aliens, And in the enormous vastness of space, we could be all alone. Connect with Catalyst on Facebook, Twitter, Instagram, YouTube, and our website.